Students, I am Ankit Tyagi and we have completed chapter solid state, and from today we are going to start a series which will be based on the question and answer. So in this chapter we will discuss approximate 66 question. So these are very important. If you will cover these question, there is no need to do anything for the board examination. Okay, so here you can take the quick revision of the chapter. Number of particles at corner are 8 and their contribution is 1 by 8, so total particle is 1. For face, contribution is half, total particle is 3. So everything you have studied in the previous classes. Okay, so this is the relation between A and R. You can take the screenshot. Relation between A and R, volume. Okay, this is the volume. This is the volume of unit cell. It was the volume of sphere. And now packing efficiency. Okay, so we have completed all these topics. Now first question is that what is semiconductor? So already I told you that which will conduct the electricity only on heating. Okay, describe two main type, p type and n type. How do they work? Mean their mechanism. How does p type semiconductor work? So you will say on adding the impurity of the previous group element having lesser number of valence electron to that element. Okay, for example I am taking the example of aluminium. So if I will add the impurities of not aluminium, I am taking the example of silicon. So if I will introduce the impurities of aluminium, so aluminium has 3 valence electron, it has 4 valence electron, so there is a one vacancy. Okay, one hole for the electron. Okay, here are 3 electron, here are 4 electrons. So if you will compare impurities with this, so you will observe here is a deficiency of 1 electron. So electron can move to this side where the deficiency is there. So here the conduction of electricity, mechanism of the conduction of electricity is the positive type, means that deficiency type. Okay, this is p type semiconductor. And n type, suppose I am taking the example of silicon in which valence electron are 4. Okay. Now I am introducing the impurities of phosphorus. It has 5 valence electrons. So if you will compare the impurity with this element, you are observing there it has extra electron. So this extra electron can move from one place to another place. So it will be responsible for the conduction of electricity. So this type of semiconductor is known as n type. Okay, so there are two main types. You can watch the video number 8. Okay, you will get everything about semiconductor and band theory. Second question is that what is the total number of unit cell in the face centered cubic structure? So it is asking the number of particle. So how many particles in face centered cubic unit cell? 4. How? Face centered cubic unit cell is made up of the when the sphere are present at corner as well as faces. So how many particles at corner? 8, and their contribution is 1 by 8. How many faces are there? 6, and their contribution is 1 by 2. So total number of particle is 4. This particle is known as unit cell. Okay, now come to the third question. What type of substances exhibit antiferromagnetism, in which there is equal number of parallel and anti-parallel alignment of magnetic moment of unpaired electron? So they will cancel each other, neither they will reinforced or oppose the applied magnetic field. So such type of substances are known as antiferromagnetic substances. For more detail you can watch last video, that is video number 10. How would you account for the following fact? Frankel defect does not found in alkali metal halide. What is Frankel defect? When suppose these are opposite ion, plus minus plus minus plus minus. Okay, these are here. This is the structure of solid. What happens Frankel defect? Cation lose its dislocate from its size to the interstitial side. It comes in this area. This area is known as what? Interstitial site. Okay, so only small size cation can move to this interstitial site, because large size cation cannot fit in this area. And that's why we know that alkali metal has very large size, so they cannot take this position. That's why this defect will not found in the alkali metal halide. So you will say because of large size of metal. Okay, it cannot take the position of interstitial site. Next is Second part, Schottky defect lower the density of the related solid. So what happens in the Schottky defect? In a crystalline solid, suppose this is a crystalline solid, so what will happen? Equal number of cation and anion will move outside from the solid. Okay, so there is a vacancy. So as you are observing here, mass of this area has been lowered, so density is directly proportional to the mass, so density will also be lowered. That's why Frankel defect lower the density of the related solid. Okay, you can watch the defects or imperfection in crystalline solid, वीडियो मैंने वो डाल दिया. Impurity doped silicon is a semiconductor and it is the semiconductor of extensive semiconductor. There are two types of semiconductor. Intensive, that is the element which will act as pure metal, act as semiconductor but in the pure state. Okay, so impurity doped silicon is a semiconductor because silicon generally when it is doped with aluminium or any other element, then its conductance increases, but it conducts the electricity on heating only. That's why this is semiconductor. Okay, question number 5, explain the following properties giving suitable example. For suitable example, you will watch the video number 10. Already I have discussed ferromagnetism, in which magnetic moment of individual electron will reinforce the applied magnetic field. This is the individual alignment or magnetic moment of electron, and this is applied magnetic field. So you are looking, the magnetic field of the electron is in the direction of applied magnetic field. This is known as ferromagnetic substances, and these are used to prepare the permanent magnet. And paramagnet, when the alignment of individual electron is randomly movement, okay, with respect to applied magnetic field, these are slightly attracted towards the magnetic field. And ferrimagnetic, there is a unequal number of parallel and anti-parallel. It like this, unequal mean 3 are in the direction of applied magnetic field but 2 are in opposite direction, so it will be cancelled by this, it will be by this, but this is in the direction of applied magnetic field. So such type of solids have very less magnetic behavior, which will attract towards the applied magnetic field. Okay, for more detail you can watch video number 10. What is the coordination number of each ion in the rock salt type structure? So students, rock salt generally is a NaCl type structure. Rock salt mean NaCl, and we know that every sodium is surrounded by 6 chlorine. How many? 6 chlorine. And every chlorine is surrounded by 6 sodium. So coordination number of each atom is 6. Which point defect in the crystal does not alter the density of relevant solid? Right now we discussed it is Frankel defect, because in Frankel defect cation just loses its position but it remains inside the lattice. Okay, suppose this is the structure, so here this cation will take the position of interstitial site but it will remain inside the solid, so density will not be changed by this defect. Next is, which point defect in its crystal units increases the density of solid? Impurity defect, when you will add some impurity. Okay, for example, NaCl is doped with calcium chloride, so what will happen? Calcium will take the position of sodium atom. Okay, impurity defect. Or metal excess defect, here density will be increased, some extra cation will take the position. Now next is question number 9, why do metallic and ionic solid differ in their conductivity? So metallic solid will conduct the electricity in solid state but ionic solid cannot. Suppose it is NaCl and it is iron rod, so iron rod can conduct the electricity in solid state, but NaCl will conduct the electricity in aqueous state only. When it will be dissolved in water, it will give free ions in water, not in the solid state. So this is the characteristic. Okay, now question number 10 you will do yourself, but I am giving hint. Density of the metal is 9.95 gram per centimeter cube. If the radius of copper is 127.8 picometer, if the copper unit cell is simple body एंड सेंटर्ड, फेस सेंटर्ड, ये आपको बताना है. तो स्टूडेंट्स व्हाट विल यू डू? डेंसिटी इज गिवन टू यू D. Okay, you will put the formula D is equal to Zm upon A cube into Na. Okay, you will use this formula. So what will you do? You will find Z. You will find Z, and you will do this question in. You will do this question 3 times, and you will give me the answer by commenting. Okay, what will you do? First, take the answer. Take the density 9.95 is equal to Z. You have to question mark. Z आपने निकालना है. M, what is that? Copper. So you will check what is the atomic mass of copper, 63.5 or what? You will say, suppose I am saying it is 63, okay, or 58 something. Okay, you will do by yourself. Then what will you do? You will put the relation between A and R. Okay, what is given to you? Radius. So suppose I am taking, it is the example of simple unit cell. I am taking the example of simple unit cell. What is the relation between A and R? A is equal to 2R. Okay, 2R cube into, you will put the value of Avogadro number 6.022 into 10 raised to the power 23. But students, when you will put the value of radius, that is 127.8, so you will multiply it by 10 raised to the power minus 10 to convert it into centimeter. Okay, now you will find Z. So students, what did you do here? आपने यहाँ जो A is equal to 2R रखा है, ये सिंपल क्यूबिक यूनिट सेल का रखा है, तो आपका Z का आंसर 1 आना चाहिए, क्योंकि सिंपल क्यूबिक यूनिट सेल में क्या होता है 1. अगर आपका ये 1 नहीं आ रहा तो आप फिर से फॉर्मूला यूज करोगे, डेंसिटी इज इक्वल टू Zm अपॉन A क्यूब इंटू Na. सपोज करो अब मैं इसको मान के चल रहा हूँ फेस सेंटर्ड, सो यू विल पुट द वैल्यू ऑफ डेंसिटी, इट इज 9.95 इज इक्वल टू Z आपने क्वेश्चन मार्क है, और कॉपर का आप एटॉमिक मास पुट करेंगे पीरियोडिक टेबल से देख के, और A इस बार सपोज करो फेस सेंटर्ड है, तो A इज इक्वल टू कितना होता है 2√2R. R की वैल्यू आप कितनी लेंगे? R की वैल्यू कितनी लेंगे आप? 127.8 इंटू 10 रेज़्ड टू पावर माइनस 10. ओके, होल क्यूब कर दोगे इंटू 6.022 इंटू 10 रेज़्ड टू पावर 23. सो अगेन यू विल कैलकुलेट Z. अब आपने फेस सेंटर्ड क्यूबिक यूनिट सेल रखा है, तो Z का आंसर आपका कितना आना चाहिए? फेस सेंटर्ड के लिए Z का आंसर 4 आना चाहिए. अगर 4 आया तो इसका मतलब फेस सेंटर्ड क्यूबिक यूनिट सेल है. अगर ये नहीं आता, देन अगेन यू विल राइट D इज इक्वल टू Zm अपॉन A क्यूब इंटू Na. अगेन यू विल पुट द वैल्यू ऑफ डेंसिटी 9.95 एंड यू नीड टू कैलकुलेट Z. अगेन मास रखना है आपने कॉपर का. नाउ सपोज आई एम कंसिडरिंग दिस यूनिट सेल एज बॉडी सेंटर्ड. सो व्हाट इज द रिलेशन फॉर बॉडी सेंटर्ड? 4/√3R whole cube into 6.022 into 10 raised to power 23. So again you will put the value of R, which is 127.8 into 10 raised to power minus 10 का आपने क्यूब कर देना है. तो अगर आप बॉडी सेंटर्ड का रख रहे हो तो Z कितना आना चाहिए? 2 आना चाहिए. अगर 2 आया Z तो ये बॉडी सेंटर्ड है. यू विल राइट द आंसर इन द कमेंट बॉक्स. ओके, सो 11th क्वेश्चन, व्हाट टाइप ऑफ सेमीकंडक्टर इज नॉट ID is obtained when silicon is doped with arsenic? So students, silicon belong to the group number 14, carbon, silicon, germanium, tin, lead. Okay, and arsenic 15 group, nitrogen, phosphorus, arsenic. So by trick you can do this question. When the impurities of next group are added, so semiconductor will be N type. Okay, so consider this is the element and it is doped by silicon, arsenic. So arsenic belongs to the next group, that is higher group, so it will be the N type semiconductor. Okay, 12th question, which point defect does not alter the density? Again we have completed this question. Answer is Frankel defect. What is the distinguished feature of metallic solid? They can conduct the electricity in solid state as well as in molten state, but ionic solid not. Okay, now next question is that question number 14. In 14 question, क्रोमियम मेटल क्रिस्टलाइजेज इन बॉडी सेंटर्ड. सो बॉडी सेंटर्ड Z इज इक्वल टू कितना हो गया? बॉडी सेंटर्ड 2. ओके, एज लेंथ ऑफ द क्यूबिक यूनिट सेल फाउंड इज A इज इक्वल टू 287 पिकोमीटर. ओके, कैलकुलेट एटॉमिक रेडियस. R इज इक्वल टू क्वेश्चन मार्क. सो फॉर बॉडी सेंटर्ड A इज इक्वल टू 4/√3R. सो R विल बी A √3/4. So A is 287. There is no need to convert it into सेंटीमीटर, क्योंकि हम डेंसिटी तो निकाल नहीं रहे ना. एंड वैल्यू ऑफ √3 1.732 एंड इट विल बी डिवाइडेड बाय व्हाट? It will be divided by 4. Okay, so you will find the answer. Rest of the calculation you will do yourself. It is clear to all or not? Okay, next is last question for today. Give one example of ionic solid which will show Frankel defect. So answer is AgBr. So you will keep in mind that this is the example which will show Frankel as well as Schottky defect. So students, I hope you will love this video, and in next 3 videos we will complete all this exercise, and this assignment consists of 66 questions. Thank you.